Welcome students. Now we will see the third subsection, return and risk for portfolios. In the previous subsections we have seen individual securities, average return, the expected return, the variance, standard deviation, covariance and correlation. Now we will see how to do those calculations of expected return, the standard deviation, variance, covariance, correlation, all these things, how to calculate in a portfolio of securities. What is portfolio of securities? In the portfolio of security, we have more than one security. Here example is taken, same stock fund and bond fund are taken, and let us consider 50% of the money invested in stock fund, 50% of the money invested in the bond fund, and we have the individual securities expected return available, variance available, standard deviation available from the previous section. Now, taking those individual securities expected return, variance and standard deviation, if we assume 50% in bond fund and 50% in stock fund, how to calculate the expected return, variance and all for the portfolio? Let us do it. Here the left hand side panel is for the individual securities, stock fund, bond fund, the yellow shaded area, and the right hand side shaded area is for the portfolio. Here for the portfolio's expected return is equal to the weight of bond fund multiplied by return of bond fund plus weight of stock fund multiplied by return of stock fund. So, for example, under recession, we need to calculate the portfolio's possibility of return. How to calculate that? Weight of bond fund is 50% multiplied by return of bond fund is minus 7%. Plus weight of stock fund is 50%. We have assumed 50% in bond, 50% in stock. So weight of stock fund is 50% multiplied by the return of stock fund is 17%. Will give you the possibility of return of the portfolio under the recession. Same we can calculate for normal and boom, 9.5 and 12.5%. Same way, the weight of bond fund multiplied by the possibility of return of bond fund plus weight of stock fund multiplied by possibility of return of stock fund. This is the way we calculated the possibility of return for the portfolio. Now we will calculate the expected return of the portfolio. Expected return of the portfolio is equal to weight of bond fund multiplied by expected return of bond fund plus weight of stock fund multiplied by expected return of the stock fund. How to do that? Weight of bond fund is 50% multiplied by expected return of bond fund is 11% plus weight of stock fund is 50% multiplied by expected return of stock fund is equal to 7%, will give you 9%. This is the way we calculated the expected return of the portfolio. Now it is the turn for variance. Variance of the portfolio is equal to weight of bond fund multiplied by standard deviation of bond fund to the power square plus weight of stock fund multiplied by standard deviation of stock fund to the power square plus 2 multiplied by weight of bond fund multiplied by standard deviation of bond fund, weight of stock fund multiplied by standard deviation of stock fund multiplied by correlation of bond and stock fund. Here some of the books, some of the authors, what they do, they open this. Then the formula will be weight of bond square multiplied by stock of standard deviation of bond square plus weight of stock square multiplied by standard deviation of stock square plus 2 multiplied by weight of bond standard deviation of bond, or we can write 2 multiplied by weight of bond, weight of stock, standard deviation of bond, standard deviation of stock multiplied by correlation of bond and stock. Some of the authors, they use like this. They open the formula and they write it in this way. Again I am reading weight of bond square, standard deviation of bond square, plus weight of stock square multiplied by standard deviation of stock square, plus 2 multiplied by weight of bond multiplied by weight of stock multiplied by standard deviation of bond multiplied by standard deviation of stock multiplied by correlation of bond and stock. This is the way some of the authors they represent. Both of the way the same answer will come. Now using that we got the standard deviation of the portfolio 3.08. Let me tell you how we calculated it. Let me explain you here. What is the formula? Weight of bond square, that is 50% square multiplied by standard deviation of bond square. Standard deviation of bond is 8.16 square plus weight of stock square 50% square multiplied by standard deviation of stock square 14.31 square plus 2 multiplied by again go back to the formula, so that's why I explained the other way. 2 multiplied by weight of bond multiplied by weight of stock, 50% multiplied by 50% multiplied by standard deviation of bond 8.16 multiplied by standard deviation of stock 14.31 multiplied by the correlation of bond and stock, that is we have calculated in previous 3 slides, minus 0.99. You have just calculated here, minus 0.998. So once you use it, you will get it 3.08 as the standard deviation of the portfolio. Hope it is clear. Again I am reading. Now I will directly read the values. I will put it 50% square multiplied by 14.31 square plus 50% square multiplied by 8.16 square plus 2 multiplied by 50% multiplied by 50% multiplied by 14.31 multiplied by 8.16 multiplied by minus correlation 0.996 will give you 3.08. This is the way we calculate the standard deviation of a portfolio. Here, of course, once you do it in the spreadsheet, it is too easy, and we can calculate the different portfolios standard deviation return in the data table method. We can calculate it within a second, and here the author has calculated for the bond and stock funds. Weightage started from 0% to 100%. That means 0% in stock, 100% in bond, first one. Then 5% in stock, 95% in bond. 10% in stock, 90% in bond. Like that he has gone, and we have calculated 50%. That's why it is shown in red font. 50% stock, 50% bond. We calculated return 9%, standard deviation 3.08%. Here we calculated. Return is 9% and standard deviation is 3.08%. So this is the way the different weights and the return and standard deviations can be calculated, and it can be plotted in a graph. And this we call it as efficient set of risk and return for two different assets. So note that some portfolios are better than the other. You can see, for example, 0% stock, 100% bond gives you 8.2% risk, 7% return. But if you go to 5% stock, 95% bond, you find the difference, return increased, risk decreased. So it is a better portfolio. Next, you made 10% stock, 90% bond. You have seen return has further increased, risk has further decreased. 15% stock, 85% bond. Return has further gone up, risk has further gone down. These are the better portfolios. 20% stock, 80% bond. Return has further increased, risk has further decreased. This is the way it has gone up to 35% stock. 35% stock, 65% bond will give you highest return, that is 8.4%, with the lowest return 0.4% risk. So it depends on the risk return appetite where you stand. So you find better than other portfolios, many better options are there. You 5%, better than that is 10%, better than that is 15%. So always you find better than the others where return is high with the same or less amount of risk. So here is when we calculated correlation, one of you asked me the question, so what do we mean by correlation? If you are taking 100% stock, that means the correlation will be 1. You are not diversifying at all, so your correlation will be 1. If you are taking 100% bond also, correlation will be 1. But if you are in between, your correlation will be varying from -1 to +1. If it is +1, that means there is no diversification. If this is -1, perfect diversification. So, from this 100% bond to 100% stock, we have calculated the different in between correlations. And the perfect correlation is when it is -1.0. And as I explained you during the correlation question, it always vary between +1 to -1. So equal to or greater than -1, equal to less than 1. Always correlation vary in between -1 to +1. +1 means no diversification, -1 perfect diversification. Now we will find the efficient set for many securities. What happens? We have in our previous example, we have seen the different set of combinations here, like 0% stock, 100% bond, 5% stock, 95% bond, 10, 90, 15, 85, like that. You moved up to 100% stock, 0% bond. So different set of portfolios you have drawn. So based on that, if you plot in a graph, you find returns you plot in the y-axis, risk you plot in the x-axis, that is the standard deviations you put in the x-axis, the returns or the expected returns you put it in the y-axis for different combinations like 0% stock, 100% bond, 5% stock, 95% bond, 10% stock, 90% bond, like that proceed and 90% stock, 10% bond, 95% stock, 5% bond, 100% stock, 0% bond. So different set of portfolios of different proportions you have taken and calculated the return and risk. Where you calculated the return and risk, here you calculated the return and risk. These return and risk you have plotted in a graph. After that, what you found? All these are, once you put in the graph, you have found three different things. What are they? One is the highest return. You can see on the top of the all these kind of return combinations. In the top, the high return is there. Because return you are putting in the y-axis, so the top one is the high return, and the low return is the bottom one. You just draw a curve. After that, calculate the lowest risk in the x-axis. So the extreme left one will be the lowest risk. That will be the minimum variance or minimum standard deviation. We have calculated the average and standard deviation. Based on that, the extreme left one will be the minimum risk portfolio. So that will be the minimum variance portfolio or minimum risk portfolio giving the lowest standard deviation. That is the extreme left one. Then you draw a efficient frontier. Which are the things you have considered for drawing the efficient frontier, dear friends? One is the highest return. The other one is the lowest return. and lowest risk. You just draw the efficient frontier. Once you draw the efficient frontier, question comes, why the return differs? What are the component of the return? So I'll stop the recording here. Just give me a minute.